Hello everybody, I'm Pablo Leibovich from the Institute of Technological Research for Networks and Electrical Equipment, Argentina. Let us start with the paper presentation called Design and Implementation of a Low-Cost PMU, Validation by Tests and Performance during 2019 Argentinian Blackout. Well, phasor measurement units are the main part of new smart power system grids. Due to its high temporal resolution, synchrophasor technology has become popular, so several applications for grid monitoring, control and protection are being developed. In this context, many well-known manufacturers are now producing PMUs as part of sophisticated protection devices, but with high costs for developing countries. Considering this economic aspect, a complete low-cost three-phase PMU design, implementation, and test are described in this paper, based on previous studies about measurement techniques and transmission methods. It also showed its performance in comparison with the commercial PMU, IEEE standard compliant, and measurements of the PMU during the Argentinian blackout of June 16, 2019. Based on available commercial embedded systems such as ARM microcontrollers, a low-cost three-phase PMU was designed and tested. The design includes 3 voltage measurement channels and 3 current measurement channels, with the corresponding isolation and electrical protections, a GPS receiver providing the timing signals, a microcontroller-based acquisition and processing module, and an Ethernet interface for synchrophasor transmission over Internet. To validate the design, and due to the unavailability of a signal generator with the corresponding precision for PMU tests, the measurements obtained in the same node were compared between the implemented PMU and a commercial PMU compatible with the IEEE standards. We can see in the images some photos of the PMU and its graphic user interface. The deviation of the measurements within the compared PMUs was very satisfactory. More details about the design and tests can be found in the paper. As I mentioned before, the PMU performance during the 2019 Argentinian blackout was also analyzed. On June 16, 2019, a nationwide blackout took place in Argentina. System was operating within its limits, with a demand of approximately 13,200 megawatts when a failure in a 500 kilovolt transmission line took place. A malfunction of the automatic generation disconnection protection system, that is the DAG protection system, failures in the sub-frequency release for load shedding, and the premature disconnection of generators were the causes for the system collapse. These failures can be seen in the event sequence shown in the image below. During the failure, the implemented PMU was connected and measuring at the low voltage distribution network in La Plata, Argentina, 60 kilometers far from the city of Buenos Aires. In the figures are shown the direct sequence voltage amplitude, the frequency, and the roll-off. It can be seen that an oscillation started at 7 a.m. and 6 minutes and continues during 3 seconds, when the blackout took place. Also, it can be analyzed that frequency dropped from nominal levels to values lower than 49.5 Hz before the blackout at the place where the PMU was installed, while roll-off values detected were under -4 Hz per second. Measurements of the PMU were compared with those obtained from the SCADA records, validating the PMU. To conclude, a low-cost PMU based on actual embedded system technologies and commercial components was obtained. The resulting cost for this PMU is $560, which is much lower than commercial solutions that include the PMU as a component of the system, and makes the design suitable for technology migration in developing countries. Based on previous studies, the PMU was optimized to transmit synchrophasors over Internet. Finally, the implemented design was validated by comparisons with the commercial PMU, and its performance was evaluated during Argentinian blackout. Thank you very much.